So we're going to jump off here from the stretching of the world onto a sheet of paper and do the same thing with other shapes and objects. This branch of mathematics is called topology, and it's a lot of fun, and it ends up with knot theory and all sorts of good things. But for now, let's just dive into this particular handout. The whole idea here is we're allowed to stretch things, but we're not allowed to rupture things. So the first of these is pretty easy. We have our rectangle, and the top and the bottom we're just going to identify, and then we're going to be left with two circles on the ends. And if we bend the whole thing around, we can just lock those two circles together. And that, if you sort of think about it for a bit, gives you a donut. Well, that's all cool. How is that different from the fourth one? Well, the fourth one, you could bend those two bits together that go in the same direction, but unfortunately now you've got these end bits that go in opposite directions, and when you go to bend them back around, they won't match up. The arrows are going in the wrong directions. They're sort of back to front. Part of the problem is that the Klein bottle, which is number 4, doesn't actually exist in 3 dimensions. So you could instead bend it back in through itself, come back out one of the sides, and then go there. Now the problem is you'd have to go through one of the sides. Now if you lived in 4 dimensions, that'd be okay. You could have the side bit here live at sort of 0, and when you come out through that same sort of space be at 1, and then come back down. The other interesting thing about the Klein bottle is that it's a one-sided object. So you might have seen the Möbius strip before, where you take a piece of paper, you give it one twist, and then you match it together. And now if you were an ant, you walk along that piece of paper and you walk around it once, you end up on the other side of the piece of paper. Well, the Klein bottle's kind of the same. And the Numberphile YouTube clip that I've included a link to here, that actually shows you the ant walking around. It's kind of amazing. I think your students will absolutely love it. As for the second and third question, those two actually make the same object. It's called a double-holed torus, or a two-holed donut. So sort of if you imagine 2 donuts sort of pushed together and joined in the middle bit there. To see that from the octagons that I've given you, it requires a little bit of mind bending and sort of pushing it out and sort of drawing some pictures to get there. But I'd let the students struggle with it for a while, and then at some point towards the end, have a look at the second YouTube clip that I've included, because that actually gives a really nice visual version of how we take one of those octagons and turn it into a double donut. All right, let them wrestle with it. Remember, there's mind bending and stretching going on here. We're just not allowed to rip.